You think the universe had a beginning, 13.8 billion years ago. The Big Bang, time itself started. Before that, nothing. No space, no time, no matter, no energy, just nothing. Then suddenly, existence, creation. The universe began. That's the story everyone knows. That's what cosmology teaches. Extrapolate backward, space contracts, temperature rises, density increases. Eventually you reach infinite density, a singularity. That's the beginning. Time, zero. Before that, nothing. The universe started from nothing at the Big Bang. This seems like established science, confirmed by observations, the cosmic microwave background, Hubble expansion, Big Bang nucleosynthesis, all pointing to a hot, dense beginning. Except it's wrong. The universe did not begin, cannot have begun. The very concept of cosmic beginning is confused, incoherent, based on extrapolations beyond where the physics applies. And understanding why there's no beginning changes everything about existence, time, and why there's something rather than nothing. Let me start with the standard story so you see where it goes wrong. The universe is expanding, galaxies moving apart, space itself stretching. Run this backward. Earlier times had smaller separations, higher densities, higher temperatures. Keep going back. Eventually you reach a hot, dense state, the early universe. This is well established, observed. The cosmic microwave background is light from when the universe was 380,000 years old, hot plasma cooling, becoming transparent. We see that light, red-shifted by expansion. We see the early universe, hot, dense, real. That's not controversial. But extrapolate further back, before the microwave background, before nuclei formed, before quarks were free. Keep going. The equations of general relativity say if you extrapolate far enough, you reach a singularity. Infinite density, infinite temperature, infinite curvature, all the matter and energy compressed to zero volume. That's what the equations give you if you trust them all the way back. Time equals zero, the Big Bang singularity, the supposed beginning of the universe. This is where the confusion starts, because that singularity is not a prediction, it's a breakdown. The equations giving infinity means they've failed, stopped working, reached their limit of applicability. You've gone beyond where general relativity applies. General relativity is a classical theory. It doesn't include quantum mechanics. At the densities and energies near the supposed Big Bang singularity, quantum effects dominate completely. You need quantum gravity, a theory combining general relativity with quantum mechanics. And we don't have that theory, not completely, not in a form we can calculate with reliably. So we don't know what the equations say at the earliest moments. We can't extrapolate to a singularity because the theory breaks down before we get there. The singularity is not real. It's where our description fails, where we need new physics, where quantum gravity takes over, and quantum mechanics hates singularities. Quantum uncertainty prevents infinite density. You cannot compress matter and energy to zero volume. The uncertainty principle stops you. The more you squeeze spatially, the more momentum uncertainty grows. Eventually you create particle-antiparticle pairs. Energy spreads out. Pressure resists compression. Quantum effects provide a bounce or a floor, something preventing infinite density. Singularities are classical artifacts. Quantum mechanically, they resolve into something else, something finite, something without infinite values. The Big Bang singularity almost certainly doesn't exist, not as an actual physical state, just as where classical general relativity breaks down. So what happens instead of a singularity? We don't know for certain. But several possibilities exist. Quantum bounce models. The universe was contracting before, reached minimum size at Planck density, then bounced, started expanding. The Big Bang is really a big bounce. Not a beginning, but a transition. From contraction to expansion. The universe existed before, was contracting, bounced, now expanding. No beginning. Just a turning point, a bounce from quantum gravity effects. Before the bounce, more universe. Earlier times, earlier contraction. How far back? Maybe infinitely far. Maybe the universe is eternal, always contracting and bouncing and expanding and contracting again, cyclic, no beginning, no end, just cycles. Or maybe time itself is emergent, doesn't extend infinitely into the past, but not because there's a first moment, because time is not fundamental. The Wheeler-DeWitt equation describes the quantum state of the universe. It's timeless, has no time parameter. The quantum state just is, static, not evolving. Time emerges from correlations within the state, from how different parts relate. Clock degrees of freedom correlated with system degrees of freedom. That correlation is what we experience as time. But fundamentally, there's no time, no evolution, just quantum state. If time is emergent, then asking what happened before time emerged is meaningless. Not that there was a first moment, but that before doesn't apply. The question is malformed. Stephen Hawking proposed something similar, the no-boundary proposal. Near the Big Bang, time becomes imaginary. Not imaginary like fake, imaginary like the complex number I. Time in the equations gets multiplied by I. And when you do that, space-time becomes four-dimensional space, no time dimension. The Big Bang is not a moment in time. It's a region in four-dimensional space, a place, not a time. There's no before because before requires time, and time doesn't exist there. It emerges as you move away from the Big Bang region. The universe has no boundary in time, finite but unbounded, like the surface of a sphere. Finite area but no edge. Similarly, space-time is finite in time but no beginning. No boundary, no first moment. The universe just is. Timeless at the fundamental level, time emergent at larger scales. All these models avoid the singularity, replace it with something finite, quantum, well-behaved, and none of them have a beginning. The bounce models have infinite past, cyclic or monotonic. The emergent time models have no beginning because beginning requires time and time is emergent. The no-boundary model has finite time but no boundary, no edge, no first moment, different approaches, different mathematics, but agreeing on one thing, no beginning. The universe does not start, cannot start. The question of beginning is confused, applying time-based concepts where they don't apply, or assuming classical general relativity works where it doesn't. Now let me tell you about eternal inflation. This is the most popular model of the very early universe. It solves the horizon problem, the flatness problem, the monopole problem, explains why the universe is so uniform and flat and simple. Inflation is a period of exponential expansion. Very brief, very early. A tiny patch of space inflates to cosmic size in a fraction of a second. That patch becomes our observable universe. Inflation ends. Space reheats. Hot Big Bang begins. That's standard inflation. But most models of inflation are eternal. Inflation doesn't end everywhere, only locally, in patches, pocket universes. But globally, inflation continues forever, always happening somewhere, always creating new pockets. This is eternal inflation. And it's almost unavoidable if inflation happened at all. Here's why inflation is eternal. The inflaton field has quantum fluctuations. It's a quantum field, so it fluctuates. In some regions, fluctuations push the field down toward the minimum of its potential. Inflation ends there. That becomes a pocket universe. But in other regions, fluctuations push the field up, away from the minimum. Those regions keep inflating, and they keep having fluctuations. Some regions stop, others continue. The regions that continue grow exponentially, dominate the volume, create more regions, more fluctuations. Some stop, others continue. It never ends. Globally, inflation is eternal, always happening somewhere, always creating new pockets, infinite pocket universes. Each one looks like a Big Bang to observers inside. But globally, no beginning, just eternal inflation. And eternal inflation extends infinitely into the past too. Not just the future. If inflation is happening now, then it was probably happening earlier and earlier and earlier. No natural starting point, no reason for inflation to start. If the field can be in the inflating regime, it was probably there before. Always, eternally. So eternal inflation is past eternal, no beginning, always inflating, always creating pockets. Our Big Bang is one pocket nucleating, one bubble forming. But the inflating background is eternal, was always there, always will be. No cosmic beginning, just eternal process creating local beginnings. Does this prove the universe has no beginning? Not definitively. Some argue eternal inflation might have a beginning despite being eternal to the future. The Borda-Guth-Vilenkin theorem. It says inflationary spacetimes cannot be extended infinitely into the past, must have a boundary, a beginning. But the theorem assumes classical spacetime, assumes geodesics can be defined and traced backward. Quantum gravity might violate those assumptions, might allow past eternal inflation after all, or the boundary might not be a beginning, might be a quantum state, timeless, no first moment, just transition from quantum to classical, from timeless to temporal. The BGV theorem doesn't prove a beginning, just proves classical space-time can't extend infinitely, but classical space-time breaks down, becomes quantum, and quantum might have no beginning. So eternal inflation suggests no beginning, and even if there's a boundary, it's probably quantum, not a moment in time, not a beginning, just where classical description fails, where quantum gravity is needed, and quantum gravity probably doesn't have beginnings, doesn't have first moments. Quantum mechanics is fundamentally timeless in some sense. The Schrödinger equation evolves states, but the states exist timelessly in Hilbert space. Evolution is our perspective, not fundamental temporal flow. At the deepest level, quantum states just are, timeless. And if the universe is quantum, then it's timeless. No beginning, no end, just eternal quantum existence. Now let me address the objection. If the universe had no beginning, then it's infinitely old. How can something be infinitely old? Doesn't that create problems? Infinite past means infinite time elapsed. How do we arrive at now? How do we reach a moment after infinite time? This is Zeno's paradox for cosmology. The paradox assumes time is real and infinite and we traverse it. But time might not be real fundamentally, might be emergent. And even if time is real, you don't traverse infinite time. Each moment is reached from the prior moment, finite duration. Infinite past doesn't mean infinite duration traversed, just means no first moment. Every moment has a prior moment. No beginning, no contradiction, just unfamiliar, counterintuitive, but not paradoxical. And quantum mechanics removes the problem entirely. If time is emergent from quantum states, then there's no infinite time to traverse, just timeless quantum structure, the appearance of time, the appearance of flow, but fundamentally no time. No traversal, no paradox. The universe just is, quantum state. Correlations creating appearance of time, of past, of future, but fundamentally timeless, eternal in the sense of being outside time, not in the sense of lasting infinite time. Eternal, like mathematics, is eternal, timelessly existing, not enduring through time. That's deeper, more profound, more correct. The universe is timeless, not infinitely old but ageless. Eternal not in time but outside time. What about creation then? If the universe has no beginning, was it never created? Does it just exist necessarily? Many religions and philosophies assume creation, a creator, a first cause, something outside the universe bringing it into existence. But if the universe has no beginning, this picture fails. Nothing created the universe because there's no creation event, no beginning to explain. The universe exists, always existed, in some form, maybe not this form, maybe not in time, but existing, being, not created, not beginning, just being, eternally, necessarily. not contingent on anything external. This seems unsatisfying. We want explanation. We want to know why the universe exists, why these laws, why this structure. But maybe existence doesn't need explanation. Maybe existence is fundamental, necessary, not contingent, not created, not beginning, just being. Asking why the universe exists is like asking why mathematics exists. Mathematics just is, true necessarily, not created, not contingent. The universe might be similar, existing necessarily, not because something caused it, but because non-existence is incoherent, impossible. Nothing is impossible, as I've argued before. So something is necessary. The universe exists because nothing is impossible, and something must be. And quantum mechanics supports this. Quantum fields exist, fluctuate, cannot be removed, cannot be reduced to nothing. Quantum mechanics is eternal, not starting or stopping, not created or destroyed, just existing, necessarily. The structure of quantum theory is timeless, mathematical, necessary. The universe's quantum structure exists necessarily, not created, not beginning, not contingent, just being. The laws of quantum mechanics are the structure of reality, and that structure is eternal, timeless, necessary, not contingent on anything external because there is no external. The universe is all there is, exists necessarily because nothing is impossible and structure is necessary. What does this mean for cosmology? It means the Big Bang is not a beginning, not the origin of time, not creation from nothing. It's a transition, a phase change. The hot, dense state we extrapolate to is not the beginning. It's a moment in eternal existence, a transition from prior state to subsequent state, maybe from contraction to expansion, maybe from quantum to classical, maybe from one phase to another, but not from nothing to something, not from non-existence to existence. The universe exists eternally. The Big Bang is an event in that eternal existence, important, defining our observable universe, but not the beginning, not creation, not origin of existence itself. And it means cosmology is about transitions, not origins, about how the universe changes, not how it began, about phases, not creation, the early universe, inflation, reheating, hot Big Bang, nucleosynthesis, recombination, structure formation, galaxy formation, all transitions, all phases, all moments in eternal existence, not beginning but evolution, not creation but transformation. Cosmology is history, not creation mythology, history of an eternal universe. Phases and transitions, not origin and creation. Does this contradict observations? No. All observations are consistent with no beginning. The cosmic microwave background shows the early universe was hot and dense. True. Expansion is real, observed, true. But none of this requires a beginning, only a hot, dense phase, a transition, an event, not creation. The data is silent on whether there was something before. General relativity extrapolates to singularity, but breaks down before reaching it. Quantum gravity needed, and quantum gravity probably avoids singularity, provides bounce or emergence or timelessness, no beginning, no contradiction with data, just different interpretation, more careful, more correct. So why do people say the universe began? Because the equations naively suggest it. Because extrapolation gives singularity. Because we're not careful about where physics applies. Because we confuse our observable patch with the whole universe. Because we impose time-based thinking on timeless structure. Because beginning seems intuitive. Creation seems necessary. First cause seems required. But it's not. It's confused. The universe has no beginning, cannot have beginning, existed eternally, in some form, maybe as quantum state, maybe as inflating space, maybe as mathematical structure, but eternally, necessarily, not contingently, not created, not beginning, just being. Why the universe has no beginning? Because beginning is incoherent for the universe. Beginning requires time. Time is part of the universe. The universe can't begin in time because time is internal. Beginning requires cause. Cause requires prior state. Prior state is part of the universe. The universe can't be caused by something external because there is no external. Everything is universe. So the universe can't begin, can't be caused, can't be created, just is, exists eternally, timelessly, necessarily, not contingently, not created, but existing, always, in some form, maybe not this form, maybe not in time, but existing, being, eternal being. That's what the universe is. Not beginning, not ending, not created, not destroyed, just existing eternally. And that's not a problem. That's not mysterious. That's just how reality is. Eternal, necessary, being itself, not contingent being, not created being, but necessary, eternal being. The universe, existence, reality, being. Eternal, necessarily, no beginning, no end, just being forever, timelessly, necessarily. That's the truth. That's reality. That's what the universe is. Eternal being, no beginning. And understanding that is understanding existence itself, not as contingent, not as created, but as necessary, eternal, just being, the deepest truth. The universe has no beginning, never did, never could, just exists, eternally, necessarily, being itself. That's the answer, that's reality, that's truth.